The OSI Reference Model separates network functions into categories. This separation of networking functions is called layering. The OSI Reference Model has 7 layers. Each one illustrates a particular network function. Let's take a look at these layers. The first one is the physical layer. This layer defines the very basics when it comes to networks. For example, voltage levels, timings of voltage changes, physical data rates, maximum transmission distances, physical connectors, and other similar attributes. And you need these specifications to define the actual signals, connectors, cables, and so on so that you get the network going. For example, if something doesn't work and your coworker says to you, "Check layer 1 first," he means that you should go and check if the device is connected and plugged into the electrical grid. Next up is the data link layer. As the second layer, it defines how data is formatted for transmission and how access to physical media is controlled. This layer also typically includes error detection and correction to ensure a reliable delivery of the data. Do you know which devices are considered layer 2? Those would be switches. The network layer is the third layer. The network layer provides connectivity and path selection between two host systems that may be located on geographically separated networks. With the growth of the internet, the number of users that are constantly accessing information from sites around the world has increased dramatically. So the network layer is the layer that manages connectivity of these users by providing logical addressing. A typical representative of layer 3 is a router and an IP address. On top of the network layer is the transport layer. For example, business users in large corporations often transfer large files from field locations to the corporate site. Reliable delivery of these files is important. So what the transport layer does is it breaks down large files into smaller segments that are less likely to experience transmission problems. TCP and UDP are the protocols that operate at this layer. TCP is used when data loss during file transfers cannot be tolerated, and UDP is used when some data loss is acceptable. Normally, that would be video streaming, where speed is important. The session layers establishes, manages, and terminates sessions between two communicating hosts. It also synchronizes the dialogue between the presentation layer of two hosts and manages their data exchange. For example, web servers have many users, so there are many communication processes open at a given time. As a result, it's important to keep track of which user communicates on which path, and this is done using port numbers. The session layer takes care of the presentation layer, and this layer makes sure that the information that is sent at the application layer of one system can be read by the application layer of another system. For example, when a PC program is communicating with another computer, each computer might be using a different encoding scheme. The last one is the application layer. Each networking administrator will tell you that this is where programmers dwell, and that a networking expert doesn't really need to care about this layer. Well, that is true. However, I'm sure an IT admin would also prefer to use a nice graphical interface when it comes to reading emails, and that is what layer 7 is all about. It provides services only to applications outside of the OSI model.